This short video, we will discuss some basics about how radar works and how to use it to guide your storm spotter efforts. The typical radar imagery you see on TV, phone apps, or online, it uses what we call reflectivity. This is an indication of how much of the outgoing signal is returned to the radar. This depends on a few things. For example, larger raindrops will be more easily detected than smaller drops associated with drizzle. The targets also have to be close together, as a certain amount of the radar beam width needs to be filled for the radar to process it. The type of target is also a factor. Besides precipitation, the radar can also pick up flocks of birds, clusters of insects, and objects on the ground. The highest reflectivity will show up from either a mixture of rain and hail or from non meteorological targets such as smoke from a fire. Velocity images represent the actual Doppler part of Doppler radar. Velocity is inferred by measuring the frequency shift between radar pulses. It lets you know if a reflected object is moving toward the radar or away from the radar. Remember that the radar beam height increases as you get further away from the radar, so what you may see may be a considerable height above ground level. This is an example of a velocity image. In this image, the radar is located off the northeast corner of the image. Areas in green represent motion toward the radar, and areas in red show motion away from the radar. When these two extremes show up right next to each other, it typically signifies a rotating storm, potentially tornadic. However, this is not always the case. Using the same radar image as the previous slide, now imagine the radar is actually to the southeast of the storm rather than to the northeast. In this case, the wind is flowing in opposite directions rather than rotating around a fixed point. Thus, if you use this type of radar image, it is important to know where the radar is in relation to the storm.